Hey everyone, we're just going to give folks a chance to log in and then we'll get started. All right, we'll get going here. Welcome everyone. Thanks for joining us today. Today's webinar is co-hosted by the New York Oracle User Group and Viscosity North America. My name is Monica Lee, Marketing Director at Viscosity, and I'm so happy to have you guys here. If you are regular attendees with us, thanks for coming back. And if you're new, welcome, welcome. We've always got great content for you guys. So keep up with NYOUG and Viscosity for more webinars like today's. So a little bit first before I hand it over to Coleman from NYOUG. Today's webinar is live, which means please ask questions. You've got a great technologist here with you today, Craig Shallahamer. So take advantage of this time with him. He'll get to questions as he can throughout or at the end of his webinar. Also, today's webinar is being recorded and you'll be able to find it at nyoug.org or at www.orapub.com. I'll tell you a little more about that later. But for now, we're going to let Coleman tell us about NYOUG.
Thank you, Monica. So New York Oracle Users Group was formed almost 40 years ago for the exchange of ideas, assistance, and support among users of Oracle software products. You can connect with us on Twitter, Meetup, and if you have any abstracts, please submit it. We're always willing to give another person speaking time for our webinar sessions. LinkedIn, Facebook, and of course the website, nyoug.org. And thanks Viscosity North America for this ongoing series of webinars co-hosted by the New York Oracle Users Group and Viscosity. And thanks, Craig, for speaking today. And Craig will go in a little bit about himself in a moment.
Awesome. Thanks, Coleman. And then real quick, I'm going to tell you guys a little bit about Viscosity. We'll make it quick because I know we all want to hear from Craig. All righty. All right, so if you're not familiar with Viscosity already, we are a full Oracle Stack consulting firm. Sorry about that. Full Oracle Stack consulting firm with core expertise in Oracle database, including RAC, Oracle Apex, zero downtime migrations, performance tuning, and high availability. We've got decades of experience with infrastructure, including engineered systems, and currently we've been upgrading many of our customers to Oracle Database 19c. We host monthly workshops and webinars through orapub.com. And as you can see here, these are the three pillars that Viscosity is built on. So if you look at this bottom row right here, these are all the things that we offer throughout all three of these pillars of data, apps, and infrastructure. So from proof of concepts to training to managed services, you can definitely turn to Viscosity with your confidence and we will take care of you. If you recognize any of these folks on the screen, these are some of our Oracle ACEs. They write all of the books that you need. They write the blogs you should refer to, and they're speaking constantly throughout the Oracle community and more. So definitely check them all out. You can follow them on Twitter. All of them have their own blogs. And we've also got a ton of books that they write. We don't even have them all up here, but again, across the three pillars, we have trusted authors on our team like Craig today. So hopefully you guys own some of these books already. Also, as of the first of the year, orapub.com is now powered by Viscosity. Craig, who's speaking to us today, is actually the founder of Orapub, and he's been providing training and being an advisor to many people throughout the world, honestly, through Orapub, and now it's part of Viscosity, and we're so happy to have him on our team. So again, all of our webinars are posted here at orapub.com. You can become a free member and see most of it. Paid members get a little extra perk. We've also got a lot of workshops. Some of them are multi-day workshops that you can actually pay for and hopefully ask your employer to refund you on, because it's great training and you're only going to help your organization more. So with that, last slide here before we get ready, events.viscosityna.com is where you can find where we're going to be, whether it's in person or online. And my colleague, Katie Barnes, she will be emailing everybody at the end of today or start of tomorrow with resources such as Craig's slide deck today and where you can find the recordings on NYOUG or Viscosity. All right. So with that, I'm going to turn it over to Coleman. I don't know if you want to introduce Craig, or Craig, if you want to just go for it.
Coleman, I'm ready if you are.
Craig,
Okay.
go for it.
All right, let me share my screen here and we'll get going. I should get the right screen. All right. Can you guys see me okay? I think you can.
That's good.
All right. So, hey, I'm not in my, well, welcome, by the way. And I'm not in my normal office today. And I'm staying at some family. And so you're going to be looking at my nose for a while because I got a big screen up above me and I'm all that kind of stuff. So bear with me. It might get a little awkward. Did you hear that? That was a cock-a-doodle-doo. All right. So what we're going to talk about today, I'm going to talk about machine learning. And specifically, the type of algorithms we're going to focus on to make predictions is going to be called deep learning. And they're artificial neural networks, super fascinating. And they are like, the future. I don't think that's too crazy of a statement. So how we're going to use those so we can relate that to our life as a DBA or a developer, as an Oracle professional. We're going to be predicting the next average active session value. And we're going to use AWR Sysmetric summary data to do that. So most of today is going to be a demonstration. It's almost like I'm going to use what's called a notebook, and then instead of using slides, I'm going to I put text in the notebook as well as the actual demonstration. So you're basically going to get like a little mini book instead of just a slide deck. So you can actually work through this, do the exact same thing I'm going to do. And I made sure that if you just take your DBA Sysmetric summary, table view, whatever, SQL developer, export it to a CSV file, you can just, boom, you can use that to do exactly the same thing I'm going to do. So you can play with your data, which is always interesting when you're actually using your data. So that's what we're going to be doing. If you got any questions, go ahead and just chat those in. I have the chat on my screen right here. And actually I could, yeah. And I should be able to see that. So I recognize some names. It's really good to see you guys in here today. All right, so let's go to the next slide here. All right. So this is what the demo is going to look like. That's average active sessions in real time. You're going to see this go. So it's pretty fun to actually watch that. So a lot of people ask me, Craig, I'm a DBA, can I do this stuff? So I like to show this slide right here. It says, yeah, as an Oracle person, you can do machine learning. And there's a learning curve because there's a lot of new things, a lot of new words. There are things that have been reworded or given new names for what we're used to, which always is kind of irritating, but that's just kind of the way it is. So yeah, for sure you can do it. And so hopefully you'll feel a little bit like this after today. So my background has been, I founded Orapub with my wife, Katrina. And I'm a Viscosity's applied AI scientist, the coolest title I've ever had in my life. And I've been doing Oracle work since 1989. So I'm an Oracle ACE director, and I'm on the board for the Utah Oracle User Group. But they have their big conference coming up in, I think, in September. So we're going through abstracts right now. So that's a real quick, background. I dress like that every day on the upper right hand of the screen, as you can imagine. So yeah, Viscosity is awesome. They're the one company when I wanted to do more machine learning, I talked to them and we worked it out. All that Monica said, and more. Super fantastic people. I've known them for years. So there are a lot of their focuses on data, trying to get value from data. So what we're going to do today, we're going to get some extra value that's kind of hidden value out of some Sysmetric data. And hopefully it turns out really good for y'all. So interesting, my machine learning journey. Some of you probably recognize this. I dug this up just this past week because I thought, I've been intrigued by this stuff for many, many years. So in '87, I got a hold of Turbo Prolog, and that kind of just launched myself into this whole area of predictive and machine learning and all that. Wrote a tic-tac-toe program to play itself in 1990. I started working with neural networks in '97 before they were like deep learning. Okay, and then I'll describe the difference. I actually did a presentation in 2001 at the Rocky Mountain Oracle User Group using neural networks. It took me 2 years. I did not accept the first abstract. I know they're thinking like, what are you doing, Craig? And it was pretty fun. And I wrote a forecasting book. It does not have neural networks in it. So don't, if you're interested in, that's not where you go for that research. Super great book though. I'm really proud of that. And I got a couple classes right now, and there will be some shorter term workshops. Just finished the machine learning 2, which is predictive analysis, and what's called supervised learning, which is what we're going to be doing today, as opposed to anomaly detection, where we use what's called unsupervised learning. And we'll talk a little bit about that. So here's the focus for today. Okay. Real quick on use cases. The slides I'm going to go through are the deep learning specific slides. And then we're going to go right into the project. And I'm going to bring you through actually a number of things. And there's a lot more detail that I'm not going to cover. Okay, there's a lot more text that I'm not going to read through to you guys. It's for your reference. I'm going to kind of talk, demo, and so you can go back if you're really interested in this stuff. So that's the plan. Okay, use cases. I can't see the chat here. I'm going to do a window move here. There we go. Let's see. All right, use case. This is something I always put this in my presentations, so people say, hey, what can we actually do with this? Okay, if you're an Oracle professional, probably the easiest way you can use this, whether or not it's embraced by your IT organization, it's better monitoring and alerting. Okay, and the goal here is you have all these production systems. We need like a red light to start flashing to draw our attention to the system that actually needs like human intervention. Okay, so that's what we're trying to do. It can scale, the self-learning, the rules just adjust. And I think that'll become clear as we actually go through this. I was listening to an interview by Elon Musk, and it was awesome. He was talking about some of the details about the machine learning stuff. And he actually said this. He says, machine learning eats rules and code for lunch. And what he meant by that, and he actually explained a little bit too, is that initially when they started doing all the self-driving cars, it was much more if there's a tree, don't go there. If there's a sidewalk, don't hit. It was all these if then. It was all these just heuristics. Boom, if then, if then, if then. And what they're doing with neural networks is what he's talking about. And some very specialized neural networks, and they write it in just C code, right? Really close down to the hardware. He says they're replacing all those heuristics with neural networks. And the code is shorter, it's faster, and it works much better. And so I thought that was really interesting since we're talking about neural networks today. So, okay, let's get right into supervised learning using deep learning neural networks. Now, supervised learning, what that means is we have historical data. We have both the inputs and the outputs. Okay, like we have a bunch of attributes about Oracle performance, and we know the result, like performance was bad. And so we're going to train our model, right? We're going to supervise its learning. So given certain inputs, it will learn what the output should be. So if it then receives information similar to that, some data, it's going to say, oh yeah, performance has been bad in the past. When I saw this pattern, Craig, it's going to be really bad, that kind of thing. Okay. So that's what we're going for here. So there's a lot of text in here, so I'm not going to read through this because you guys can too. I want you guys to know that neural networks it's not a new thing. Okay. 1943 is when some of these guys were, wrote a paper on it. I started working with it, was it 97 when I first, saw it. So that's quite a few years after that. It's all based on, ANN is artificial neural networks. It's based on understanding and kind of trying to mimic how our brains actually work. And if you really get into what people know about how our brains actually work, it's amazing how little we actually know, that kind of thing. So okay, this is important. So you have these neurons. Let's say this is like a neuron right here, this little cap right here. All right. So it's going to receive inputs. Okay. These inputs can come from other neurons. That's what makes it a network. So it receives all these inputs, it sums them up. And then if there's like enough energy, right, then it will like fire and boom, it'll shoot output to any other neuron that it's connected to. And so that's how you get this network, and it kind of just goes through as you have all these neurons just firing. And if you've ever seen one of those animations of the brain where you see little flashes going off and they're sending messages, that's the neurons firing is what that's all about. Okay. Okay, how many neurons? I did some Google searching on that. Okay, humans, I guess around 86 billion neurons. Cats have like 0.76, dogs 2.5 or 2.25, and then the sea sport has 231, and apparently a sponge has 0 neurons. Okay, and the next slide I have a bunch of other animals just for your reference because it's actually kind of funny. Cockroaches have surprisingly large number of neurons. Anyways, all the learning that we're going to talk about, it's actually driven. Okay, it's just not just spontaneous thing like what questions should I solve? No, we are giving it the question that we need an answer to, and we're writing the code, and there's a driven objective. It's not just like this emergent, alive kind of thing. That's not quite what where we're at here. Okay, we also use what's called this is a buzzword here, regularization. Essentially, we actually turn off some of the neurons to make it more difficult for the model to learn. And what this does is it makes it more difficult for the algorithm to develop a model that essentially memorizes the data. Okay, memorization is bad, learning the patterns is good. It's like when we learn any subject, we really don't want to just memorize it. We want to understand it. So when we get a question similar to what we've studied, we know what the answer probably is. Okay, so that's why it's all about patterns. Okay. Now for neural networks, they're organized in layers typically. Okay, so you can have 3 different layers, like 1, 2, 3, and they could each have like 10 neurons. So you have a total of 30 neurons, and they're all connected together. And I'll show you, a picture of that coming up. Okay, so neural networks it's really nothing new. Okay, but deep learning, if you hear the term deep learning, okay, that's taking it to a whole nother level, because these neurons here are not just really simple, sum the input, if it's big enough, boom, you fire. That's what really makes it deep learning. And I'll mention that in just a few minutes here. Okay, so here's some of the neurons. Okay, this is the slide, screenshot it if you want to. Okay, in case you don't want to download the slide deck. Slide deck's pretty small. All right, there you go. I like the sea squirt sponges. I'm glad they put 0 in there, just so there's something that's like kind of alive but has no neurons. Okay, here's an example of an artificial neural network. It's going left to right. So on the left is going to be the inputs. So you can picture each one of these inputs, these X, all right, usually it's capital X is an array containing the inputs. And like one of the inputs could be like average active sessions. It could be a database time, CPU ratio, could be like transactions per second. It just, boom, it's numbers. By the way, they have to be numeric, no strings, because under all of this, it's linear algebra and it's matrices. So it's got to be numbers. Okay. So you have these inputs, and then we have all these connections with all these different neurons right here. So these are called hidden layers. The blue circles, these are just the little neurons, and they're called hidden layers because they're kind of wrapped inside both the input and the output. Okay, so basically it's kind of like it flows forward generally, although there is feedback for the type of neurons that we're actually going to use, or I should say the type of networks that we're going to use. So they're all connected, and if the neuron like fires, it passes the energy to the next neuron, and eventually you get to the output. So this type of model, I can tell just by looking at it, this is called a classification supervised learning algorithm, as opposed to a regression. In a regression algorithm, the output will be a number like 4.56. A classification is going to be something like green, yellow, red, buy or sell, right? Turn left, turn right, or go straight. that kind of thing. And so this is going to be, red or green. So when the, kind of like when the energy, flows through the network and we get to the output, if this green, this Y1 has a larger number than Y2, then the answer is going to be green. But if Y2 is larger than Y1 on the output, then it's going to be red alert, which could mean, something bad's going to happen. Okay. All right. So one last thing, these do not have to be huge. People think they got to be massive, but it's pretty amazing how much, like, I'll just say data or information they can actually hold without being just, what we would consider massive. Okay. So this is more about the summit. I'm going to skip this. Yeah, because we're going to run out of time. Okay. Okay, deep learning. All right, now one of the big differences with deep learning, just compared to normal neural network, which the traditional neural network is called a multi-layer, hidden layers, think that, perceptron, MLP. Okay, and those are simply just with these, with the neurons, or the input summed together and then it fires. It's really actually very simplistic, but it's amazing how well they do work. With deep learning, though, they're given a new name called cells. You'll hear that. I don't know, maybe they just want to give them a new name to distinguish between just, a perceptron or a simple artificial neuron. But the reason they're called cells is there's a lot of logic put inside of these. There's different gates and there's feedback and there's all sorts of stuff that's built into these. And that's what gives birth to all these different types of neural networks. And it's like rightfully so. They're just not simple artificial neurons. There's a lot going into that. And that is a very active field in research right now. They're coming out with stuff all the time. I don't hear about it first, but I'm just amazed at all the new things that are just continually, coming out. People are trying to mimic how our brain works. Just like the brain is, it's like the ultimate, the objective of this, what people are trying to do. Okay, there's a classic deep learning neural network. It's called a recurrent neural network. And it's because, as you might imagine, right, when we get some output, we got inputs, we got output. Some of it will actually get fed back into the neuron or into the other neurons in the same hidden layer. All sorts of, alternatives to that. And so those are called recurrent neural networks, or RNN for short. Okay, so the name it makes sense. There's actually feedback in there, right? And all of the deep learning neural networks seem to kind of this is where they came from. That's kind of where, it kind of birthed from that. And I could be wrong on that, but it just feels like that to me. Okay, another key word, Kuros. Sounds like a Klingon word, doesn't it? Kuros. Yeah. Okay, this is the API that we use in Python to do all this machine learning stuff. Okay, and underneath Kuros sits on top of what's called TensorFlow. Okay, a tensor is, I forget what the definition of a tensor, but if you're really into math, you might have heard of a tensor. Okay, so guess who wrote TensorFlow, right? Google did. And the first version was released in 2015, and they've actually I think they released at least one other release on that. And there are other competing platforms as well too. Okay, Facebook has one. There's some other ones out there. But anyway, so we're going to use Kuros, which is setting on top of TensorFlow, and it's going to be in Python that I'm going to be using. In fact, I'll just say right now, it's not in my notes. I use Python, Oracle Machine Learning. They have a lot of the stuff we need for machine learning built into SQL. Okay, and it's been around for quite a while, right? They tell you that, but nobody believes them. But it's actually been there for many years. Some of this stuff. For forecasting, for seasonal type, analysis, stuff like that. And it makes a lot of sense to use Oracle ML, especially if your data that you need to access is residing in an Oracle database. Okay. The bad news is, though, it's not industry standard. And if you're going to do a lot of this, you really need to use Python. That's just kind of the way it is. So I just set my course to learn some Python. If you know any other computer language, including PL SQL, you'll pick up Python. Okay, it's not rocket science kind of thing. Okay, let's see, 25 after, we're doing good. Okay, what we're going to focus on today is time series data. Okay, And what that means is that like one sample, let's say something just happened, or let's say we just got the latest AWR sample. Okay, say we're looking at Sysmetric data. Okay, like we know, but we don't think about this, but the sample we just got, the numbers there, they are influenced with what happened before, right? And then what happened before was influenced on what happened before that. So there's a temporal relationship. It's like not only do we have Klingons, we got Star Trek and the temporal anomalies kind of thing, right? We got the temporal relationships with these various samples. And we can use those, that understanding that we have time series data, that we have temporal data. We can use that to our advantage when making the next prediction, which is what hasn't happened yet. Okay. It also, we have to be really careful because we can mess up that temporal relationship when we give the data to the algorithm to then create the model. For example, is if we take temporal data, which is just like in a bunch of rows, and we shuffle it like a deck of cards, and then we give that to the model, well, we've destroyed the temporal relationship, assuming the network understands that, I'm giving you some data now, and now the next piece of data I'm giving you is related to the one prior, and all that kind of stuff is, when you give it the data like that, and it understands the temporal relationship, if you shuffle the data, it's screwed up. Okay, so we do some tricks to actually not do that, for example, shuffling, but we will also embed some historical data in each one of the samples to kind of help it learn. This is done all the time. It's called stepping, and I'm going to show you that coming up too. All right. Okay, the type of neurons or neural networks I usually use now is called LSTM. We got a page coming up on that. It's called long short-term memory artificial neural networks. Basically, it's good at sequence pattern recognition for like long sequence of numbers. Think of Sysmetric data, a lot of sequence. GRUs, which is this gated recurrent unit, it's very similar. The objectives are the same, but it's less complicated. I've used GRUs just a little bit, just in demos and, playing around and stuff like that. And basically I got the same results I did with the LSTM. So their objectives are the same. You probably don't even care about that. Okay. Images and video and recognition, that kind of stuff. They typically use what's called a convolutional neural network, or CNN for short. And it's pretty cool. It's some of the demos and stuff you can do with visual recognition, like image recognition, is actually really easy to do. And it's mind-blowing stuff. Like, is that a dog or a cat, or is that a number? Is that a 5? Like, what's that number? Oh, it's a 3. Yeah, you're right. It looks like a 3. So it's pretty amazing. So, but we're not going to use those because I haven't really got a good application with the Oracle data just yet on that, but I'm working on it. Okay, these long short-term memory neural networks. Okay, these have, remember the gates inside the neurons, right? The cells have specialized gates, so it actually learns patterns. And in other words, it's not just like, it's the old patterns and the new patterns, which is, if you think about it, when you have feedback and stuff, the newer stuff is going to tend to kind of make the older stuff kind of fade away, if I can use that way of speaking about it. But the LSTMs have the ability to kind of retain some of those older patterns, which can be very, very useful. Okay. Yeah, they're highly flexible in structure. I'm going to show you how we can actually, make those. Okay. All right. So that's pretty much it. We're going to jump right into the project. Okay. I'm going to chat this in both of these URLs. So this way you can do what I'm going to do. Don't do it right now though. Okay. But let me find my chat box here, and I'm going to put that in. So those of you that are live, hold on, there we go, can actually, grab this. Okay. So there's 2 files right there. Okay. Let me put it like this, everybody. I guess you can see it anyways, my screen. The first one is going to be a little setup document. I'm going to be doing this in what's called Google collaboratory environment. It's totally free, really easy to do. It doesn't do anything to your desktop. Just say it's Google product. It does nothing on your desktop. I don't know about that. Anyways, it's totally free. You don't have to set up a machine learning environment to use it, which is awesome. Super good. Okay. The second file here, this is an interactive Python notebook. And it'll just boot up right in Colab, and that's what we're going to use for the rest of our presentation. And I am talking a mile a minute. Can you paste? Oh, I thought I did. Oh, the host and panelist. Thank you, everyone. I did such a great job. But there we go. All right, good. Yeah, grab that. That setup doc just tells you how to basically get your Colab environment set up in Google. And I'm going to kind of quickly go through that as well. No problem, Steven. It's good to have people that I actually recognize. Michael, I noticed you're on the list there. Hope you're doing good, man. Getting ready to go backpacking. All right. Project details, blah, 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 blah. That's for your reference. That's what we're going to do. Okay, so here we go. All right. So what you're going to want to do is you got to use Chrome, use a Gmail account. Everything works good. All right. Yeah, you probably know that, but I just want to say that again. Okay, so go to your Google Drive. What you need to do is you're going to click New. Well, you want to create a folder. Call it OraPub. In the notebook itself, it's coded to look in your OraPub Google Drive directory. You can change that, right? But if you don't want to, then have a folder. Okay, and you create a folder. Super easy. Now, you have to like install Colab. Okay, so you go to More, and then you go to More Apps. Okay, see, mine's already there, but you're going to go to Connect More Apps, and you're just going to do a type for Colab. Boom, right there. That's it. Okay, install the extension or whatever it is. Okay, and then you're gonna get that notebook file, that IPNYB whatever notebook file. By the way, it has to end with that. It can't end with .txt, right? Or on a Mac, be careful how you download that. It can't be a TXT file. So go into your OraPub directory and just drag that file right into your OraPub drive. Okay, this is the file right here. Okay. Now double click it, and boom, you got the cool little Colab thing going. And we are ready to roll. There we go. Okay, and I got it nice and big so we can see it. Okay, I'm going to move some of the stuff out of the way. I want to make sure we have full screen access for this thing here. Okay. Getting more information. Yeah, I love it. All right, here we go. So this is called a notebook environment. It's very similar to what's called a Jupyter notebook, which is like the industry standard, very similar. So everything's divided up into cells. You see that little highlight right there? Okay, there isn't one here. This is like a text cell. But see that little button right there? What you do is when you write the code, you can write it in a particular cell, and then you can evaluate or run just the one cell. So it's a fantastic learning environment. And it's a great way to code too, because you don't have to run the entire program, just parts of it. Yeah, it's really fun. I love it for learning. Okay. All right, so here we go. Today's the 24th. Yeah. Okay. So okay, this runtime. So there's different ways you can run the notebook. If you want to run the whole thing, you just click that. Okay. If you want to run just one cell, just click the little play button. And you can also do a shift enter. Shift enter. That works like on every notebook I've ever used. And so that works good too. So one thing you need to make sure that you have this enabled, Google Drive true false. Make sure that's set to true. It will be set to false by default, because that's how I actually run this on my desktop using another platform. Okay. Which is called, I didn't have the yeah, anyways. In the setup instructions, it shows you how to set up a desktop environment to actually run this instead of Google Colab. So set that to true. Make sure, if you're using OraPub, if you have to change that. Let's see, learning true. That's why we get all the learning stuff. You are not doing development. Don't do that. Okay, there's some stuff that's going to do that you don't want it to have to do. All right, so I'm gonna click this thing. It's going to go. It takes a minute for it to initially go. It's connecting, doing what? Oh, so there's a virtual machine underneath this thing, and there it is. Python 3. Oh, it's using a GPU. I think it knows that we're using neural networks, and so it wants to use, a GPU. Since neural networks, everything's matrices underneath, and so GPU is just you get like a huge performance boost. Okay, so everything looks good there. We're set. Now, what we're going to do, we want to use the Google Drive. We want the notebook to interface with the Google Drive. So this is what this is about. So I'm going to say, yeah, sure, Google, I want to give you full access to my Google Drive. Scan, read everything, memorize it, and then resell it to other people. Yeah, that's okay with me. So that's what I'm doing. It's attempting to mount. There we go. So we're good. Okay. So I'm trying to kind of help you out here. You evaluate the cell. There's nothing for you to change. So those of you that's been to my machine learning classes and that, stuff like that, what I'm doing now is I have all the functions that I'm going to call in a separate Python file, and it's located, on one of my machines. That way I don't have to put all the stuff in the notebook, which really complicates it. It makes it so much easier to do. So this is actually going to go to this URL. It's going to grab this Python file, which is nothing but pure Python functions. And then we're going to reference those throughout the whole presentation. So it makes it really easy. And of course, you can download this file, the Python file, right? I mean, it's going to be there. So this is actually going to save it in the Google Colab environment. It will not save it on your Google Drive. I didn't do that. This way you always get the latest if you go out and get it. Okay, so it saved it. It's all there. Let's see, we're not working in a local environment. That's true. Okay, it's getting the file. Boom, boom. Let's see, standard Python import for project library. It did the import. That's what this is right here. Basically imported that file. Now you don't put the .py. It expects it to be there. And we can reference any function there by prefixing it with the OP. So you're going to see that. OP is for ORPUB, of course. All right. And then just because I'm paranoid, I did a reload just to make sure everything is good. If I get a reload, then I know things actually did happen correctly. Okay, so we're just going to import some Python libraries right now. Nothing fancy about that. Okay, time series prediction. Now there's a few things I want to teach you. Okay, and I'm actually going to go through this pretty quick, but we still have almost just a little over 20 minutes, so that's pretty good. So time series, like I mentioned, makes things tricky, but also gives us a huge advantage because of the temporal relationship. The trick is we need, when we give the data to any machine learning algorithm, right? We want it to learn the patterns, right? Or the absence of a pattern, think of it like that. So, but we're dealing with sequential data. So you can look at it like this right here, like the sequence. Let's say this is just one number. Let's say it's average active sessions, okay? So there's 0, 1, 1, 2, 3, 5, 8. So what we'd want is it to actually learn what the next number is going to be. So if I give it this pattern and I say learn, when I give it like a 5, I would want the model to say, oh, Craig, the next number is going to be around 8. That would be awesome. Okay. And so look at this first pattern, this first question. So look at the first series. If the average active session value is 2, is once the algorithm has learned the input data, okay, if I then say, hey, average active session of 2 just happened, what's the next one going to be? And what would you, given this sequence, what do we want the model to predict what's going to happen after 2? Okay, well, it's not tricky, right? We expect it to say, oh, after 2, it's going to be 3. Okay, and that would be great. But look at the second series here. This is a longer one. Let's say the average active session was 2. Well, what would we expect the model to give us for the answer? Well, look at that. Well, here's a 2. So we would say, okay, the next one's going to be 1. Oh, but wait, here's another 2. And the answer is 3. And here's another 2, and that answer is 3. So one of the 2s, we got a 1. And 2 of the 2s, we get a 3. So what's the right answer? Well, somewhere in the middle. That's what it's going to do, unless we can give it some information before the 2, maybe 0, 1, 2, and then it knows it's going to be a 1. See, if we can give it some historical data, if it learns the sequence, it should be able to figure that out, especially if we have this sequence repeats, and it kind of reinforces the actual learning. So it's not always, so simple. Okay, so what I want to show you here is we need to give the algorithm the attributes of performance as well as what the next prediction is going to be. Okay, so the attributes of performance, let's say this is just the sequence. Let's just say this is average active sessions. Okay, now normally this is stored in an uppercase X. I think it just comes from matrices, or f of x, that kind of thing. So these are the attributes of performance, and these are typically called features. Think of it, features of performance, attributes of performance. They can be columns. A lot of times we'll call them columns because they'll be arranged in a tabular format. But this will be a numeric Python array that we're going to create with this. Okay. The question here is, what about Y? Okay, Y is the output. Okay, and that's called the label or the target. Remember, this is supervised learning. So we give it both the inputs and we give it the outputs, which is going to be the Y. Remember the neural network I showed you with the picture? We had some X, we had some X's over here, some hidden whatever. Yeah, I've got a brain freeze there. Layers, hidden layers. And then we have the outputs. The outputs are the Y. That's the labels it's called. That's what we're going to label performance. Okay. So what's Y going to be? Well, so we got 3 options right here. Okay. So if what we're saying here is that if the model sees a 0, we want it to say 0. No. If the model sees a 1, we want it to say 1. No. We don't want to train that, right? Remember, we're going to sequence here. So if we give it a 0, we want it to say 1. And if it sees a 0 and a 1, we want it to say 2. So this is not going to write. We're going to train the model incorrectly. It'll learn it, but it's not what we want. Okay, option B is another option where if it sees a 0, we want the label, the answer, to be a 1. And if it sees a 1, we want the algorithm to learn that the next number is going to be a 2. That's good, right? And if it knows that the sequence is a 0, 1, and a 2, we want it to be able to actually say a 1. And look, there's the 1. So if it sees a 0, 1, and 2, we want the answer, the target, to be a 1. And if you think about this and you look at it, you'll notice we've actually shifted the label array. We basically copied, there's our X, we've copied it, and then we've shifted it, okay? And that's what you do, because we give the algorithm for every sample, AWR, snapshot, right? We give it all the attributes of performance and the label on one row or one array row or one table row, not only the inputs, but the outputs. So if we need information that's in the next row, we have to move it up. Otherwise the algorithm is not going to learn that. So here's a different perspective of this. Essentially what we've done, we've taken X, we've copied it, and then we've shifted it up 1. And so what the model will receive is a 0 and a 1. It'll receive a 1 and a 2. That's what it's going to learn. And if we want to, it'll start to learn, the past information as well to help it. Okay. So the pattern here, right, is that we're shifting the labels Y up, or you can look at it to the left, depending upon whether you're going horizontal or a vertical on this. Okay. And so that's really important to understand. All right. So here's an example of how we actually do. I'm not going to get into the Python right here. I'm going to run this, evaluate this. But these are our initial X and Y, and this is the length. There are 12 elements here. Okay. And so we did the shift right here. This is how you do this in Python. super elegant, extremely confusing when you first start, using this. And I'm not going to get into this, but that's how you do it. Okay, this is going to move that last row. We're going to remove the last row because you'll notice in X, we don't have a 5 here. Oh, come on, man. Yeah. And we've actually shifted our label to the left. And that's what this does right here. So that's what we do to get our data into the correct format, assuming it's time series data. That's what we're going to do. Okay. So that's the first thing I want you to learn. Now, one of the reasons I gave you this notebook, so you can go back and you can play with this, you can look at it, all that kind of stuff. Okay, scaling. Scaling is extremely important. There's a couple of machine learning topics we're going to talk about. One was time series. We're going to talk about scaling, and I'm just going to throw in one other one here, and then we're going to run this thing. Okay, scaling is very important. It's just something that you do, and the reason is some of the numbers we get can be like galactic scale, and some can be like quantum scale. And algorithms tend to favor or give an importance to a larger value. But in reality, quantum scale numbers can be more important than the galactic scale numbers. We just don't know. Or you might have some of your numbers come in inches and some come in centimeters. They're just completely different, scales, right? Kind of thing. And so we need to rescale or scale our numbers. And one of the ways that we can scale is called standardization. And it does this. It does this for every feature. Okay, features are like columns. And what it'll do for, like, let's say one of the features is, database time per second and that's all, they have just all these different rows. And one of the columns is that database time per second. And if we standardize that, it's going to take those values, it's actually going to change those values. It's going to transform them. So the smallest value is a 0 and the largest value is a 1. That's what it's going to do. It's going to proportionally change all those. And now you can change the minimum and the max, but the typical is 0 to a 1. Okay. And so let's see how this works here. We're actually got some code right here. We're going to load some data that's like this publicly available data. It's called the IRIS data set. You'll see people, mess with that or use that all the time. And so without looking at the code, you can go back here and look at it. But here we go. There we go. Before any scaling, let's just take a look. This is whatever that is. I don't even know how to say that. That length, sepal, these are the actual values. This is the raw data set. And if we do some descriptive statistics on that, we can see we have 150 samples. Okay, the average is like 5.8. But look at, the minimum is 4.3 and the max is 7.9. And if you look at the other columns here, the other features of the flower, you'll see that we have different maxes and minimums as you would expect. But when we scale this going 0 to 1, notice that all the numbers are between 0 and 1. There's nothing greater than 1 here. And if we look at some of the descriptive statistics, the minimums are all 0 and minimum all 0, and the maximum is all 1. Okay. Believe it or not, this actually is really important, especially with deep learning neural networks. Okay, you want to do this. Most machine learning algorithms want their data to be scaled in some way. Okay, all right, let's see. Last thing I really want to get into is what's called stepping. You guys okay so far? Just rolling, right? An hour is not enough. I'm going to do a workshop on this stuff it's not Collaborate, it's the Quest, the 4D conference. There's a pre-conference workshop on this, and the notebook is going to be shockingly similar to this, and you're going to get a chance to, we're going to work on it together. Okay, stepping is essentially giving historical data or adding it to each sample to help the model learn. Now, it's way easier to show you this than to talk about. So I'm going to run our little demo here of stepping. Okay, so okay, this blah blah blah. Okay, here's the output. We're going to step it once. So here's our raw data, and this is in a format called a data frame, right? Which is basically a table. It's got rows and columns, and you can see the columns are named here. F1 for feature 1, feature 2, that kind of thing. So we have 6 rows right here. We're going to step this once, and so you can see. Okay, what we're doing, we're giving historical data. So look at row 5 right here. So the first, or just, the actual data at time sequence 5 was 11, 22, 33, 22. And each one of these features could be like a different Sysmetric column. But we also want to give it what happened before, which was 9, 8, 18, 27. And so we've added it to this row. So what we will give to the machine learning algorithm will be 11, 22, 33, 22, 9, 18, 27, 18. And that will then help it determine what's going to happen next. Okay. This is done with this is an array instead of a data frame, but it's the exact same kind of thing. Okay, so we stepped at 1. Now, if you want to play with this, you go back and you say, well, I want to step it twice, give more historical data. So we just evaluate that. And now you've looked at the output, you can see, whoa, okay, there's the actual real data, the initial. Here's the step 1, and then we stepped again. And so let's look at this. We have 11, 22, 33, boom. The next, we should see a 9, 18, 18. We see that. And then we should have, the next back should be 7, 14, 21, 14. There it is. So we're going to give the model more historical data and like embedded in each sample. And this really helps the model, regardless is if it's aware of temporal data or not. You do this with decision trees too. It actually works pretty good. So that's called stepping. Okay. There's a lot of little nuances and things that we have to do and stuff but we're going to conveniently skip a lot of this. Okay. We've talked about time series. We've talked about scaling. We've talked about stepping. Okay. The last thing is feature selection. What's going to happen when you do things like stepping? You're going to get you could easily get hundreds and thousands of features or hundreds or thousands of columns. Okay. Just think in Sysmetric, we have like 140 columns. If we step it just once, we're going to have 280 columns. Step it 3 times, we're getting hundreds easily. And there's all sorts of other ways to add features to help the algorithm, learn the patterns. And so when you have a lot of features, well, you don't want to give all of them to the model because, or give all of them to the algorithm because it's a lot of data. It takes it longer for it to learn, and usually fewer features, the model performs better. It's like there's not as much noise. So the idea is to figure out the most like the best and most powerful features, and then just that data, that subset of the features, just give that to the algorithm. Okay. Now we can measure how good the algorithm performs or how good the model performs. So we'll know whether it's helping or not based upon what we do. Okay. So this is called feature selection. And there's this, I'm just going to run this thing for you. I'm not going to get into it. We just have a few minutes left right here. But what it's doing here is that, okay, here's our data right here. Okay, there's the label. Those look like all zeros. Well, they are, but there's actually 150 rows. So 50 of them are zeros, 50 are ones, and I think 50 are twos, something like that. Okay, but we're just looking at the first 5 rows here. I scaled it. Okay, now we're going to do, this is one of the algorithms, random forest regressor or regression. And it's going to say, hey, Craig, the most powerful feature is this length, followed by the petal width. Okay, now well, that's great. What I don't like is this is 4, 3, 2, 1. Well, are they really is it stepped perfectly like that? No. So other ways to actually select the best features, give us like real numbers here. And then you can see, wow, width and petal or width and length, those are the big ones. The powerful features, these things are like practically worthless. So maybe we just want to leave those off of the data we actually give to the algorithm. Super powerful stuff. There are many ways to do this. Okay. And so then what we're going to actually give to the algorithm is just going to be two attributes, 2 features, in addition to the label then. Okay. All right. So now we're getting into this. We're going to start putting all this together, and we're going to make some predictions. So I'm actually going to run this. there's this is basically going to define a function right here. And then there's like a little demo in it as well here. Okay, it's taking a while for that thing to run. Okay, so there's a bunch of stuff in here. I'm not going to go through the details. You actually you'll be able to see the flow and as we go through it. But I do want to highlight the deep learning neural network stuff, because that's kind of part of our focus here. So what we're doing here, we're loading the deep learning libraries. See, we got TensorFlow, we have Keras right here. Okay, see LSTM right there. So these are the libraries that we're actually going to use. Some of these are commented, which I didn't, unless we're needed, I comment them out. And what we're going to do, this is how we define the model. So our model, and I called it predict model, it's going to be a sequential type model, which means we're adding hidden layers sequentially. Okay, we're going to add a layer. Now this is a weird one, because this defines the input layer shape, like how many neurons. And then the number of cells, that's going to be how many cells are in the first hidden layer. So this is kind of weird. It defines both the inputs, which is maybe just a few, and then we got outputs. There can be a lot more cells if we actually wanted that. Okay, and this layer then is actually going to return not just numbers, but it's going to return an actual sequence of numbers, like a matrixy kind of thing. Okay, and we're also going to mess with this. This is called a dropout layer. This is going to randomly turn off some of these cells, which makes it really difficult for the neural network to learn our data. But it also prevents it from memorizing the data, which can be a problem. Okay, we don't want to do that. So that's what this is all about right here. Okay, now because we're returning the sequence true, it's got to give it to like the next layer. Well, here's the next layer right here. And then it also has a dropout layer in addition. So the dropout layer is like part of that LSTM hidden layer. So we basically have input, 2 layers, and then we have this dense, which everything just kind of comes into the final value. We are doing a regression model, so we're going to get a like 4.56. We're going to get a real number coming out of the other end right here. Okay, and so that's our final. And so this is how we define the neural network. It's pretty cool. I mean, it's actually really simple. You can mess with these. You can add more layers. If you want to get rid of this layer like this right here, just comment it out, change that true to a false, and you just have one layer. And you'd be surprised how good just one layer actually works sometimes. So that's what this is all about right here. Okay, so I think I did run that. Here's just some test data. And yeah, blah, blah, blah. We're going to skip that. Okay, this is the real time. Okay, this is where you get to have some fun. We'll run this for a little while, and we're gonna hit pretty good on timing here. Okay, so what's going to happen? We're going to have this chart is going to plot. And so sometimes you don't want to see all the processing details. You just want to look at the chart. So if you set this to true, okay, it's not going to show all the processing detail. A new chart is just going to flash on the screen whenever the new data has been, detected, and then, it makes the prediction. Okay. How many cycles you want to run this thing? Let's just say 100. I don't want any pause between the cycles. I just want it to go as fast as it actually can. Okay. Okay. So, how many, you can set the top features, like the names of them, if you know them. But what you probably want to do is set it to none, which is a keyword. What we're going to do, we're going to do some of that feature selection. It's going to grab just the top 5 features. And then all the remaining cycles will use as their top features what the feature selection determines. So it's a really kind of a cool way to do this. And then we're going to add some historical data, right? That's our step. And we're going to add 4 steps, 5 features, 4 steps. We're going to have like 20 features altogether when we do this. Okay, this is some of the deep learning stuff. The only thing you're going to want to mess with maybe is going to be the dropout percentage. Oh, notice in Python, I can set multiple values with commas. That's what we're doing here. So this is going to be the dropout. That's a percentage. So you can go try 5%, 10, 20, 30, just see what happens. It makes a difference. Okay, we'll talk about the rest of this in a minute here. Okay, so here's all the code. I'm just going to run this thing, let it run for a minute, and we're going to talk about it. Hear that siren? All right, so it's running. So there's a lot of stuff going on down here. Okay. It's loading some initial data. What it's going to do, it's going to save it on your Google Drive and locally on the VM here for Colab. So if you run this again, it's already there. It doesn't have to reload it every time. Okay. Here we go. Now it's loading the new data. So remember, we have some initial data, and then it's going to load the new data as it becomes available. Okay. But I'm using AWR data like CSV files for this. Now it's actually trying to find the 5 best features. So it takes a while for it to figure this out. It only has to do this once though, because the other cycles, it's going to use the same features. Here we go. And so this is going to print a graph. Oh man, a lot of stuff going on. I printed the graph. Okay, so we got that. And these are the top 5 features right here. Usually average active sessions and database time per second, those are typically the top 2 features right there. Okay. All right, now let's see, does that. Now we're going to train the model. So this is some of the input data. We don't need to actually, get into all that. This is like a summary of what our neural network actually looks like. It's an LSTM neural network. It's got our first layer right here. We've got the dropout right there. Then we have the next layer right here, its dropout. And then finally, everything condenses into just one number at the end right here. Okay, and so this is as it's learning. It's going through the data. So each epoch is going through all of our training, basically all of our training data. Okay, and it's learning. So once it goes through all the data, then this is like the loss and then the accuracy right here. We want to see this loss number get smaller and smaller and smaller. And so now it's going to go through the data again, right here, and you'll see it got the losses a little better. Goes through it again, it gets better, better. But after a while, it doesn't get any better. And I have programmed in here that if it doesn't get any better after like 5 cycles, 5 epochs, then just stop. It's like, hey, it's not getting any better, please stop. And that actually speeds things up because you don't just run for 250 epochs that way. Okay, so now this is the actual value, what happened in the past, and here is our predicted value right here. So that's what happened before. This is what we're predicting is going to happen next. In fact, I'm going to stop this right now. Okay, if that doesn't stop, which it does sometimes, go runtime interrupt. That seems to always work. Here we go. So here we go. That's what happened. This is the prediction for next. So what we want to see is a blue dot like right here. So that's the prediction. That's what happened. So it's going to run through this whole thing again, except we don't have to determine the new features because they've already been done. So this goes really fast. Okay, we go through all this stuff, all it learns, it goes through this. It took about 3 seconds, incredibly fast. But that's because we don't have a whole lot of data and all that. Here we go. So this is what happened in reality, but the prediction was up here. Well, now you might say, well, that's really bad. Well, it was around what, 6 1/4. The prediction was 8 1/2. Yeah, that's pretty far off. Now the next prediction is it's going to go down here. So we're hoping the blue dot's going to be right here. Let's see what happens. Not bad. Pretty good. Pretty good. All right. So you see what the idea is here. So let's actually go back up here, and we don't want to see all the detail now. And this is what you can do when you're all done here. I know that's really hard on the eyes, isn't it? Okay. Okay. We're going to finish up here. Clear, true. Okay. And now you can just kind of mess with the features, the steps, all that kind of stuff. And you can mess with the, really the dropout percentage. You can mess with that. You can change the neural network, how it's designed. You can do that up above. If you change something up above, you have to reevaluate the cell. If you reevaluate a cell, make sure you do everything below it. Okay. So let's just run this. And we're just going to get a little bit of information here. The first run takes longer. So, and so this is Google's GPUs we're running on right now. Okay, so it's like I'm not burning my desktop, is doing nothing other than Zoom right now, which is great. Okay, it takes a little while to figure out the best features. Here we go. There's my list. Okay, and I should now it's trained. The model is fitting right now. There we go. Okay, so if I get this right, it's just going to refresh like this every time. There we go. So now it's just, now you can just kind of see. Now we're stepping 4 times. So the first 4 or 5 predictions are always going to be crappy because the whole stepping historical thing is kind of messed up. All right, it takes a while. Okay, now is this going to make good forecasts? No. If it was this easy, right? Yeah, we would have had self-driving cars like, you know, decades ago. All right. So what I showed you is just the bare minimum, and just to get you kind of excited about this, so you can actually play with this stuff. Okay. But you will notice as you change the characteristics of the model, the dropout layers, and the number of features and steps, you'll get, you know, you will learn what works the best. Okay. And if you use your own data, then it's way more exciting to do this. So, okay. So there we go. That's what I have for you today. Let me put the slide back up here, and we'll just kind of finish up. So thank you guys for listening. If you want to get more of this, I have like a free machine learning e-course. So it's some Python, few lines of code. It'll help you learn a little bit of Python. I also have what I call a Python primer that you can actually download off the OraPub website. Go there, you can find it. Of course, I have my ML1 and my ML2 classes, which are in this kind of format, this notebook type format now. I don't have very many slides now. It's almost all in notebooks. So that's it, you guys. Thank you for joining in the class. I will release my screen. I'm hearing something. Anybody else there? Coleman? Viscosity.
Thanks, Craig. No, we're still here, Craig.
All right.
Here. Thank you so much for presenting for us today.
You're welcome. Here we go. I think I just gave you back my screen, right? Yeah.
Yeah, you're good. I hope everyone got all of that. We're going to send you all a short quiz after this.
Yeah, you'll be able to download the presentation will be up there. And you will be able to download the notebook and that kind of stuff as well. But some of you might want to do this like right now. That's why I gave you the URL so you could download stuff right away if you wanted to.
Awesome. You're always so quick to get us this stuff. So thank you so much. I hope you guys use it. If you've got any questions, Katie Barnes will be reaching out to everyone. She can either put you in touch with Craig or get you the resources you're looking for. So cool. Thank you so much. I hope you enjoy your time in Hawaii. And I hope everyone else enjoys the rest of their week. We look forward to seeing you again soon. I think we've got another webinar next week with NYOUG. So stay tuned and we'll see you all then. Thank you so much. Take care.
Bye-bye.